Welcome to Legends of Data and AI. Each episode includes inspiring and actionable data and artificial intelligence insights from global leaders across industries. Your host, Dr. Usama Fayyad, was the first Chief Data Officer at Yahoo and is Chairman of Open Insights and Executive Director of the Institute for Experiential AI at Northeastern University.
Hello, everyone, and welcome to another episode of Legends of Data and AI. My name is Usama Fayyad. I'm the Executive Director of the Institute for Experiential AI at Northeastern University and Chairman of Open Insights. With me today as our guest is a longtime friend and colleague. We've had the chance to work together at Yahoo and, of course, organizing many conferences in the KDD community, especially the applied data science track. Rajesh is a special guest because he has a long background in AI and machine learning, coming from kind of traditional software companies all the way to the online world through his journey at Yahoo, then at Groupon, then at Facebook, and now at Google, where he leads a team focusing on algorithmic data curation for Google's geo products, leveraging machine learning and computer vision to build trustworthy and useful understanding of the real world. A real challenging job, but for as long as I've known Rajesh, he has sought out challenging problems, and in particular, building pragmatic, real solutions to those problems. Welcome, Rajesh, and great to have you on the podcast.
Thank you so much, Usama, for having me on this podcast. It is an honor to be here. Before we get started, I want to mention that the views that I will express in this podcast are my own and not that of my employer, Google, or our parent company, Alphabet.
And that's good. We like it that way because we want to get your opinions and your impressions as a person having had many experiences in many different places. On that topic, perhaps you can start with kind of a summary of your background and what got you into machine learning and AI.
Usama, when I completed my undergraduate education in India, I wanted to come to the United States for further studies. My passion was high performance computing. So I actually came to the US to study high performance computing. And I came to the Iowa State University in Ames in the Midwest because Iowa State had the scalable computing labs with some of the most powerful supercomputers available at that time. In my first semester of my master's program, I took a course in artificial intelligence and absolutely fell in love with the subject to the extent that I decided to change what I specialized in. And over the course of my master's and PhD program, I focused on machine learning. And coincidentally, as I was graduating, I saw that AI and machine learning became a very popular area, even in the industry. So when I was a student, I thought that mostly it would be an academic discipline. But then there were several companies that saw the strategic value of data. And so I started my career at Allstate Research Center here in Menlo Park. It's part of the Allstate insurance companies. So that's how I got my start to the AI and machine learning career.
Yeah, and I mean, that was kind of the right thing to spot because, as at least my opinion, most of the interesting work in AI and most of the advances in AI are actually happening in companies, in the big tech giants, and in companies who have the funding and can afford to do the more advanced research, including some of the well-funded startups. And not enough, in my opinion, is happening in academia. So that was a very good choice. So with this kind of journey, this long journey, traversing many companies, how do you characterize the evolution of data and AI as your career progressed and as your viewpoint changed over time?
Yeah. My passion has always been to solve interesting and challenging problems with data. And I think I have been fortunate to focus on this aspect of my passion all through my career. Now, in terms of the evolution of data and I would say that things have changed in the following way. Number one is scale. The volume of data and the amount of computational horsepower that is now available to solve problems has just increased dramatically over the years. The second is the breadth of the data that is available. The number of different data sources, the move from traditionally structured data to semi-structured and now even unstructured like video and audio and other aspects has made it possible to solve problems that were previously considered either very hard to solve or practically unsolvable. And lastly, I would say the richness of applications. I started my career with Allstate working on insurance related problems. And now, as I have seen AI and data science grow, we are leveraging it in a variety of fields, including healthcare, the environment, the energy sector, automotive. Right? And the issues faced by industries like healthcare, the environment, automotive are very complex and require AI and machine learning algorithms to adhere to much higher standards of accuracy, of repeatability, and robustness. So this is how the field has evolved. While the problems have fundamentally become more challenging, the technology has also kept pace with.
Can you share, and by the way, I fully agree with that view. In fact, I often repeat the refrain that we don't really have better algorithms. We just have a heck of a lot more data on our hands, which enables a lot of very interesting machine learning and hence data science and AI. Can you share some stories where great value was derived from the application of AI and ML to data? Anything stick in your mind as surprising or not noteworthy? Even better,
Yeah.
anything that was game-changing, perhaps?
Well, let me share a couple of stories, Usama. The first one is from the time when I worked in your team in the Strategic Data Solutions organization at Yahoo. This was the early days of search advertising, and we were trying to determine what is the right number of search ads to show in response to a user query. Right? Now, on one hand, if you ended up showing more queries, it could lead to more short-term revenue gains, but of course, it would come at the expense of user experience. Right? Users would likely get a poor experience, especially if those ads were not particularly relevant. And so looking at the data, the search logs, as well as the ads and the user interactions with the search queries and ads, I built a model that predicted the optimal number of ads to show in response to a given user query. Right? This model not only reduced the ad footprint for us, so we were actually able to show fewer ads on average, but increase the ads revenue by several tens of millions of dollars. That, for a young practitioner like me at that time, was a very surprising result and a very satisfying result, that we were able to look at the user problem and then figure out a good way of solving it. So, this was like a win-win situation that improved user experience and also helped in monetization. More recently, Usama, we have made very good progress in using deep learning and computer vision algorithms to extract semantic knowledge from imagery. We are building a model of the real world here for Google Maps and inferring things like the detailed road network, inferring information about businesses from the images that have been captured, right? What is the title of the business, if they have their phone number displayed, or if this is a restaurant and their menu and so on, has enabled us to answer some very pragmatic real world questions like, where am I? Where can I get coffee? And if I pick a place, can you navigate me there? And coming up with the data that enables these applications has truly been very satisfactory for me personally, Because Google Maps is an application that is used by 1 billion plus users, and they are using it on a daily basis, on a regular basis to get things done in the real world.
Yeah, I mean, indeed, these applications are worth a lot, and definitely AI does play a game-changing role in those areas, and enables some things that honestly we never thought were possible without kind of humans doing them. You have experience doing machine learning in many settings in industry, and in your opinion, is most ML basically the same set of algorithms applied across domains, or are there major differences as you move from one domain to another?
Yeah, wonderful question, Osama. I feel that the foundations are pretty much the same. In order to have a successful AI or ML application, we need to keep in mind the importance of understanding the data. What is the data telling us? We need to start with clear hypotheses and have very clear success criteria. Otherwise, what happens is we tend to retrofit, um, any particular model that we have built to something that we expected to get. I learned a very important lesson early on in my career from Professor Tom Mitchell, who used to teach machine learning at Carnegie Mellon. He had visited Iowa State University to give a keynote lecture. And when graduates, some of us graduate students were chatting with him, he shared this insight. He said, I always tell my students to start out with a straw man solution. Build the simplest thing possible that gives you a baseline, that gives you a good understanding of the data. And then you can build on top of it. And I have seen that across the different industry settings, that same piece of advice holds. Now, of course, applications have evolved, right? We are now talking about autonomous driving. We are talking about AI and machine learning in healthcare, et cetera. And research has helped us advance the state of the art, right? With new algorithms and techniques that are able to tackle much more complex problems. But I still feel that the fundamentals and foundations of machine learning are basically the same.
So do you have a favorite go-to, like Strawman? Where's the simplest solution that you would start with, or the simplest candidate?
Yeah, wonderful question, Usama. It depends on the problem on hand. In some cases, if a heuristic is available, let's at least use that heuristic solution. In other cases, let's say if we wanted to build a machine learning algorithm, for classification purposes, I would use some things like decision trees. They have the advantage of being simple and to some extent interpretable. For regression, applications, I would just start with linear regression, even though, maybe having more complex interactions or nonlinear methods would do better. These strawman solutions help me to get better insight into the data and help lay the bar or help establish the bar that needs to be beat.
Yeah, and in fact, starting with the simple models often helps with the process of understanding if anything weird is happening in the data or if it can be accounted for. And that's a step that many of the beginners kind of skip and end up getting themselves in a lot of trouble. So it's good, wise advice from you, Rajesh. Let me shift gears here. I've asked many of our guests the same question, and I will keep asking it because it always surprises me that, we know that machine learning is kind of the workhorse, or really the working engine of many of the AI solutions. And it seems axiomatic that for machine learning to work, you need to have good data, detailed data, granular data, etc. But the public and many of the companies actually, with the exception of these companies that specialize in AI solutions, don't have a good understanding for the dependence of AI algorithms on data. People have no feel for like what level of data is required and how much detail is required and all of that. Why do you think that is? Why is it that the data story is not making it, including to many companies who wish to do AI, but kind of never invest in gathering the right data, like a Google or a Yahoo or a Facebook would do?
Yeah. That's a great observation, Usama, and I absolutely share that with you. Couple of reasons why I think the data story doesn't make it all the way is probably because it is not glamorous. You know, explaining to somebody that I use the coolest and the latest and greatest machine learning algorithm to solve the problem is perhaps more glamorous than saying, okay, I spent a lot of time, thinking about the data, making sure that the data was transformed in the right way, et cetera, and then use the algorithm to address that. The other thing is probably also some of the misnomers caused by the term intelligence in artificial intelligence. Sometimes people just come to think of that as, oh, as humans, we learn from very few examples, right? I mean, even as small kids, if we are shown a few shapes, the kids are able to generalize very quickly and figure out, that this is a circle, this is a triangle, this is a square, etc. Right? Whereas that is not necessarily the case for machines, at least not yet. Right. And, the more complex the problems, I feel the more important it is that you should have representative data and extensive data so that it is able to reliably and robustly solve the problem. So part of the blame lies on us as practitioners. How do we communicate this? Sometimes we communicate only the success stories, and those rely on the algorithms. But as you correctly pointed out, it is the end-to-end story. The data is absolutely crucial. In fact, there are quite a few companies and entire ecosystems that have come up that are helping other companies do data labeling, realizing that machine learning will not just magically happen if you have a handful of examples. And they are using various techniques, including even human experts, to label data and then provide it to different corporations.
Yeah. Actually, this leads to my next question very naturally. Since you've worked with some of the biggest names in technology in Silicon Valley, companies that kind of depend on machine learning, on AI for what they do and what they deliver, is there a short summary of your perspective on how can the practices in AI and data science be democratized elsewhere? What can we do to make them accessible to all 99.9999% of the companies out there who wish to use the technology but can't get there?
Yeah. In my view, Usama, there are a couple of things that companies that are interested in using AI and machine learning but haven't done so already can use to get started. Number one is really to start simple. You can take the problems that you already have insights into. For example, you may have a heuristic solution to a particular prediction problem. You don't need a large team to start with. Right? More importantly, getting the 2 or 3 people who are specialists in machine learning and data science and embedding them with the business teams allows them to understand the business context and allows the business users to see the impact that AI and machine learning can have. So, starting simple, building those solutions and demonstrating value helps organizations build that trust that yes, AI and machine learning can actually solve practical problems for us. The other thing that I would say is also making sure that companies are keeping the end-to-end problems in mind. And that includes the entire process of data collection, preparation, analysis, and then the model building. But once the models are built and deployed, it is also important to make sure that you have the right monitoring in place. Very often, the real world data might change, or the user behaviors and patterns might change. And just keeping a single model going without observation can be challenging. So just keeping a few of these things in mind can help companies get started. These days, there are a lot of tools available, even in the public domain, that allow you to take the data that you already have and run it through the machine learning algorithm. So you don't need to spend a whole lot of, let's say, resources in writing up or coding these machine learning algorithms, at least not to start with, right? The simple algorithms are all available in packages. with good visualizations and good explanations.
Yeah, no, this starting with something simple is such great advice, because most people don't appreciate the fact that, all these tech giants and the big players in AI have started with very simple stuff in the beginning. And now we're looking at them after, I don't know, in the case of Google, 20 years of doing this iteratively and so forth. And, it feels like it's so untenable for the rest of the world. So that leads me to the next natural question. Kind of, what advice do you have for companies, whether they're a large enterprise or a new startup, in terms of how to think about AI? How should they think about AI from a business perspective?
I would say AI and machine learning should be viewed as tools and techniques that allow you to solve business problems. There is no substitute to careful understanding of the problem, careful analysis of the data. AI can certainly help. It can help to accelerate the problems that are being solved. It can also help to solve problems at much bigger scale than, let's say, your heuristic solutions or other simple techniques that you were using. And so for businesses thinking about using AI from the business perspective, again, I would go back to identify the specific problem that you want to solve. Like, what are the outcomes that you're hoping to achieve? And then see if AI and machine learning can help you to get there. This is very much an iterative process. I am also a big believer in the process of A/B testing. So, when you have a new model, you can actually test it out if possible. I mean, there are some scenarios where A/B testing may not be that easy or feasible, in which case you go back to more of the tried and tested metrics and offline evaluation. But if A/B testing is feasible, doing that helps you to immediately see the value that a new model or a new algorithm can bring to your data. And then scaling that up over time is the recommended approach, in my view.
Agreed. Rajesh, what guidance do you have for students who are considering a career in AI and machine learning? What would you say to a Rajesh who's starting out?
Yeah, thank you, Usama, for asking this question. I am frequently approached by a lot of students, extremely smart students from, both high schools as well as colleges, asking me similar questions. I would say the following in terms of guidance that I would give to them. I truly believe that AI and machine learning has tremendous potential. We are just scratching the tip of the iceberg. Over the next 15, 20, 30 years, we are going to see very interesting new applications of AI and machine learning. And so if they are passionate about this area, this is definitely an area that they should pursue. They should keep in mind that it is very important to build strong foundations. Whether it is specializing in AI and machine learning, whether it is specializing in computer science or computer engineering, and you're taking some AI courses at the side, it's fine. But making sure that you have the strong foundations, both in terms of engineering practices and an understanding of these models, is crucial. Secondly, I always encourage students to think deeply about the spaces that are of interest to them. What I mean by this is what areas of practical application of AI and machine learning is interesting for them. And if they are interested in particular areas, let's say like environmental science or finance or something like that, I would encourage students to even consider doing a minor in that area. Because what that does is it helps you to understand the problems from the domain that you are interested in. It helps you to speak the same language as the people you will be interacting with, assuming you decide to make a career in that field. And lastly, my advice is to always start from the user problem that you are trying to solve. What do we want to do for the users, and work backwards from there. Do not be enamored by the latest and greatest algorithms. yes, it's important. Depending on the problem that you're trying to solve, you can certainly use those. But focusing on the user problem gives you that grounding, gives you that North Star that then enables you to deliver successful AI applications.
I know this is great advice on kind of, having that specialization area, which is a trend we're seeing definitely in data science, where you have data scientists focusing on biology, etc. And this whole thing about, walking backwards towards success when you're building a solution. I wrote a recent article on this, and it's something that, I often say to people, coming up with an amazing predictive solution is usually the easiest part of deploying an AI or a data science project. The hardest part is making sure it gets deployed in production and dealing with all the issues there. Two last questions here as we approach time. You hire a lot of data scientists and AI people, and you have over the years. What is the biggest challenge, in your opinion, facing higher education as they try to train the next generation of talent in AI and data science to meet this huge demand that we see in the marketplace, where there's simply not enough talent out there to address the open positions and the demand? What would be your advice to higher ed?
A few things come to mind, Usama. I think that universities and educational institutions are definitely being very cognizant of the demand for AI and machine learning and data scientists. And we are now beginning to see programs that are specifically geared towards these disciplines, right? I mean, there is actually masters in AI or masters in machine learning, which is great. A couple of things that I would say, are important to add to these programs is, number one, if as part of the AI and machine learning courses themselves, if we can get specific domains, problems from specific domains that students can solve as part of their projects, it gives them the experience of dealing with real world situations. Now, this is, again, a lot more possible these days. There are open source data sets or freely available data sets, including at Kaggle and other places that students can avail of. Usama, I remember going back to the times when I was a student, getting our hands on a good data set itself was a big challenge. So that would be one. The other thing that I would say is encouraging potential internships and co-curricular practical training, if possible. Different universities handle it differently. Just the ability for the students to go out and see what the real world is. You put it very nicely in one of your early statements. The real world problems are quite messy, and just getting that understanding is helpful. One of the other things that I will say, just to round this off, Usama, is, and this was my personal experience when I was at one of my previous companies, we were struggling to hire talented data scientists. And what we realized is that broadening our search and looking at other disciplines where data is equally important was very helpful. And we were successfully able to hire people, from astronomy or physicists or people with, math backgrounds. So initially, we were focusing a lot more on computer science and formal machine learning training. But we saw that some of these other fields had people who may not speak the same language immediately, but they have deep expertise in data and data science. And they made some of, our best scientists. So just thinking about broadening the scope in that sense is also helpful.
Yeah, no, I mean, this is great advice. In fact, one of the tenets of our approach at the Institute for Experiential AI is, we'd like to create, it's not just realistic data sets, but actually real projects with real deadlines and real constraints and real messy data where, half of it is missing and, maybe a third of it is wrong, right? Which is what you see in reality. I often say that we need the equivalent of a residency program in a teaching hospital for, our people to graduate and be useful on the job in data science and AI. I will end this great discussion. And by the way, a lot of this discussion brings back memories of how we were working together to establish that invited speakers track at the applied data science track in KDD, and how we wanted to make sure that the world kind of got to see these applications where the people doing them didn't necessarily have the time to write papers and participate in a classical way in a conference. Let me address the last and different part of the equation. How do we get AI technologies that we develop to be trusted by users and the public? How do we get people to feel they can safely rely on recommendations or solutions provided to them by an AI algorithm?
Yeah, this is a wonderful question. Trust in AI and machine learning, as you can imagine, is a very important area of focus, across the board, right? I mean, people from the research community are focusing on building algorithms and techniques that can be trusted. People from the social sciences community are thinking about the principles for using AI and machine learning and making sure that they are fair and equitable. I think it is very crucial for us as practitioners, to build that trust with the partners and the business folks that we are working with, because only when we have that trust will they be willing to invest more in AI and machine learning and leverage AI and machine learning techniques for future problems. Now, in order to build that trust, Usama, there are multiple aspects. Right? On the technology side, we definitely need algorithms that are reliable and robust, right? So as you pointed out, the real world data is messy, the underlying distributions might change. How do these algorithms behave when the distribution changes is crucial. These algorithms need to have very high level of accuracy, right? I mean, especially when we are dealing with mission critical applications like autonomous driving or, healthcare decisions, etc. They have to have that level of accuracy and they need to be reliable. And then on the social side, privacy is paramount. User privacy is extremely important. You are seeing almost all companies across the board paying a lot of attention to user privacy and making sure that we are respectful of the data that the users are sharing with us. But more importantly, the AI and machine learning systems need to be fair, and where possible, interpretable. I remember going many years back when I first started at Allstate. I was discussing a problem with my manager and said, oh, we could use a neural network for the solution. And he reminded me that, because of legal reasons, the algorithms that we are using need to be interpretable. And, if you're going to use a neural network, it's not sufficient to say that my black box gave me this answer. You have to think about interpretability. So this is not necessarily a new problem, but a problem that has assumed even more importance as the years have progressed.
Yeah, no, I mean it's a deep concept that spans the whole gamut from issues of understandability and explainability to issue of demonstrating reliability to issues of bringing the users along and having them understand how the system is reasoning, even when it hits the wrong answer, to the graceful degradation, which in most AI does not exist. You start getting weird stuff when something new happens, which is unacceptable. So we have a long way, like you said, to learn. And by the way, I love your advice to students of saying, get some real world experience. It's very, very consistent with Northeastern's ethos and our established 100-year-old co-op program where our students go and spend 6 months, sometimes twice 6 months with companies working on problems, which actually enriches both the companies and the students. with that, we have come to the conclusion of this episode. I am Usama Fayyad, Executive Director of the Institute for Experiential AI at Northeastern University and Chairman of Open Insights. And Rajesh Parekh of Google, thank you so much for joining us. And thank you for sharing your personal opinions and views on a very deep and varied field.
Thank you so much, Usama. I had a great time in this conversation.
And I invite you all to join us in a future episode of Legends of Data and AI. Thank you.
Thanks for listening to Legends of Data and AI. We hope you enjoyed our deep dive into the world of data and AI. If you're keen to learn more about making data and AI work in the real world and in any organization, join us next episode and subscribe to the podcast. As always, you can head over to open-insights.com to sign up for our email list, learn more about the work we do, and have access to data resources. See you on the next podcast.